Okay, I'll go over the testing homework. The first problem, problem 2, we're trying to test if the amount of detergent is more than 500 grams. We're going to assume that it's 500, and we're going to try to test that it's more than that. We need to calculate T explicitly because data analysis in Excel doesn't have a t-test when against a constant. So we calculate a t-stat by taking the sample average minus the target, 500, and divided by in the denominator of standard deviation divided by the square root of the sample size. So if you use this formula in Excel, you can calculate your t-stat, and from your t-stat you can calculate a p-value using the t.dist. It's a one-tailed test, so use the RT. That number is very small relative to the alpha, so we want to reject the null hypothesis, and we do have evidence that we have more than 500 grams. In problem 16, we're looking at two brands of batteries, and we want to know if they are different. And you can do this two different ways. One way is to use confidence intervals. And you do that by gathering some basic stats and the confidence levels or the descriptive stats and get the confidence levels, and then clicking on these and doing your design add chart element to get an error bar and use the error bar width to use the confidence level, and you can see that these error bars overlap, and if they overlap then that means you don't have evidence that there's a difference. If you want to pursue this using a t-test, you can. This particular solution I'm showing is looking at assuming unequal variances. You could have used equal variances, but I went ahead and did an f-test to test if the variances were equal or not. I found out that they were not equal, so I used a t-test assuming equal variances, unequal. You do the same thing but use equal variances. The math is going to be very similar, but this is your null hypothesis, your alternative, your alpha is 0.05. You calculate your t-value for your t statistics 0.76, and then the p-value of the two-tail is 0.44. And all that means is that you don't have evidence. You fail to reject the null hypothesis. There is no difference between brand 1 and brand 2. So you could have done this both with the confidence interval plot or a t-test that give you the same answer. Problem 18 is a paired t-test because it's the same house. And we're looking at what it appraised for and then what it ultimately sold for, and we're looking for differences. The null hypothesis is that we assume there's no difference and we try to prove that it's greater than. I used a paired t-test. You calculate a t-stat that's very small, close to 0, and a one-tailed test has a p-value of 0.36. which is much bigger than 0.05, so there is no evidence that there is a difference between what it appraised for and what it sells for. 47 is that we have data, and we're looking at several things, but in this case we're looking at the time of day that the transaction against region. We want to know that is the time that people place an order a function of which region that they are placing orders from. And so we built a pivot table first. We built a pivot table to generate the observed data. So we had our pivot table that we built. And once we have that, we copied it, and that becomes our observed data. And then the expected, if independent, we use the row total times the column total divided by the overall total and copy that for all region, time combinations, which there are 12 of them. And then we can also calculate the individual chi-squared stat. So the assumption is that they are independent. We try to prove otherwise. We calculate the chi-squared stat by summing all of these individual chi-squared numbers. And we use the chi-test formula. Again, don't forget to grab the observed data first and then the expected. If that number is really small, we would reject, but it's not. It's big, so we fail to reject the null hypothesis, and we do not have evidence that they are related, so we're going to assume that they are independent. Problem 53, I think we did this one in class. We're looking at a sales strategy. We randomly grab 32 people and ask them to implement a particular sales strategy. We have 4 choices. We have a balanced design, so we have the same number of people participating in each of the 4 plans. The null hypothesis is there's no difference, and then our alternative is at least one is different. When you do an ANOVA, because it's more than 2 populations, you can calculate your F-stat in step 4 and your p-value. That's very big relative to alpha, so we fail to reject and we don't have any difference in plans. Thanks. That should be enough for you to evaluate your homework.